Hey guys, so this is the first flip lesson for the business calculus class. We're going to deviate here a little bit from what I've been doing with the other classes. So the other classes, they've been getting the note packets, like we did all of trimester 1. And the way that the videos normally work is I would go through the videos just like it was one of our lectures in class. I would make a video for you guys, and then you guys would have the ability to just fill in your note sheet and go from there. We're gonna deviate from what we're usually doing for this particular lesson. I mean, the notes are good and stuff, but I want to focus most of this video that you guys are going to see. I want to focus it really on doing an example with you guys, and then we can come back and address some of the stuff that's here in the actual note guide when we're in class. So this being a flip lesson, you guys are just going to watch the video and take notes and try to fill in the details, or as much of the details as you can, of the note packet, and then we'll address any of your questions in class. And then the next time we have class, we will actually work on the book assignment together. We also have a classwork kind of lab assignment that we will do together in class as well. So all you guys really need to concentrate on is watching the videos that I'm going to provide to you guys, and just taking as many notes as you can, and just coming up with some constructive questions if you're confused about anything, and then bringing those to class, and we'll we'll fill in those gaps, and then we'll actually do our application or our practice all together when we're in the classroom together. So yeah, let's deviate a little bit from this. Let me switch screens here. So here we are. So what this entire section that we're going to be working on is about. This is about graphing derivatives. Graphing derivatives. So we have this concept from our prior lesson that a derivative is a slope predictor for a function. It allows us to find the slope of the tangent line of any given function at a given point. So here's what, when we're graphing derivatives, I apologize, I know I'm going a little bit back and forth here. Graphing derivatives is actually, I feel very comfortable with my calculus skills. Graphing derivatives is always something I've struggled with, because I actually have to take some time to really think my way through it. Something you guys are going to discover is that since a derivative is a slope predictor, you can graph its relationship of the derivative to its original function. So for the example that I'm going to be working with you guys, I started off with this function of f of x is equal to negative x squared. We're going to use our definition of the derivative. We'll take the limit as h approaches 0. I do all of my scratch work here. You guys should try doing this. If you guys have some blank paper or the back side of the note packet I gave you guys, I want you guys to actually try finding this. It's a good warm-up for you guys and get used to it. I have all of the steps written out here. So f of x equal to negative x squared. I go through all of the steps right here for you, get to the very end. And then I apply the limit, and I end up with the derivative of negative 2x. So f prime of x is equal to negative 2x. There's kind of an important relationship here. I'm just going to point it out to you guys. When we do something called the power rule, when we start going over the shortcuts for derivatives, you guys will see this again. There exists a relationship between the exponents of a function and its derivative. So I'm just going to point that out here. It'll come up again later when I actually generate the graph for you. So we have negative x squared. If we were to graph that, let me grab a marker here. So if we graph negative x squared, here, let me grab a different sheet of paper. So if we actually graph f of x is equal to negative x squared, that will look like this. So we have our Cartesian plane. I have this here. There is a second video also posted on myBackpack that you guys will take a look at as well, and they do something very similar to what you guys are about to see here. On here. So I'm just going to make a quick sketch of this really quick. So negative x squared is just going to be a flipped over parabola, so we end up with something that looks like this. Alright, cool. So we end up with a flipped over parabola. Yay. Okay. You guys have this concept from Algebra 1 I'm sorry, not algebra, from your pre-calculus class of what a maximum and a minimum is. This particular parabola has a maximum. We have a maximum at the origin. That's going to be important later. I wish I had shifted this up, actually. Yeah, actually, we're going to do that. I'm going to modify this all here really quick. Here. I apologize, guys. Give me just a second here. So let's draw a fresh one here. And we're going to have our Cartesian plane. Okay. And let's draw another parabola here. I'm going to use the function f of x is going to be equal to, I'm still going to use negative x squared, but I'm going to do negative x squared plus 10. Okay. F prime of x of this, I'm not going to do the steps here. You guys can actually do this to confirm it. Is going to work out to negative 2x, so it has the same derivative as our last function. All that's really going to be different here is that the graph itself is just going to be shifted up 10. So we end up with a parabola that is shifted up. Okay. All right. Wonderful. Okay. It's a sketch. Sue me. All right. What's important here is that we have a maximum at this point right here. This point, I've got a different marker here. So this point right here is going to be the point 0, 10. This happens to be the maximum of this parabola. Okay. What's important about that is that if we were to draw a tangent line here, we have this concept of a tangent line being it's the line that only touches a graph at a single point. So whenever you have a maximum and a minimum, I'm going to make a little asterisk here, whenever we have a max or a min, and you guys will see this later, we have something called the first derivative test that is kind of what we're all working towards here. It's one of the applications of derivatives, but we'll come back to that later. So if we have this line here, we're traveling up our function, we're traveling up our function, traveling up the function, and now we have instantaneous rate of change. If everything stayed the same, so it's like if I'm spinning that string like I did in class and then I let go of it, which direction does it go? I would generate a line going this way. So I end up generating a horizontal line at a maximum. Okay, it just so happens to be that I also generate a horizontal line at a minimum as well. So whenever you have a max or a minimum, okay, the tangent line is horizontal. Okay, so we have a horizontal tangent line whenever we have a maximum or a minimum. Okay, what we are trying to do is we are trying to generate a graph of what the function of what the derivative of this function would look like. You will notice here that we go from a quadratic to a linear. That's important later, especially as we start working with higher powers and stuff. You're going to see a relationship that whatever the degree is of our original function, the derivative will always be one less. So if I start with a quadratic, the derivatives of quadratics become linear. The derivatives of cubic functions will be quadratics. The derivatives of quartic functions will be cubic functions, and so on and so forth. And we'll see this later when we actually have the rules and stuff, and you guys have some shortcuts here. Let's actually graph it. If I take this point right here, okay, and I find the tangent line at that point. So we're moving up the graph, and I take my tangent line at this point. I'm going to end up with something that looks kind of like this. Okay, this has a positive slope. So we have a positive slope to that tangent line. Same thing here. If I take a tangent line at this point, okay, and again, we just draw a little line that shoots off that way. Again, we have a positive slope to this tangent line. Okay. Once we get past our maximum, though, all of these lines, all of these tangent lines, okay, will have negative slopes. Let me draw just a little bit more here. This one too will have a negative slope. So all of those lines have negative slopes. So if we were going to generate a graph of this, the slope of a horizontal line is 0. Okay, so I'm going to use green to draw the graph of the derivative here. So what we're really drawing here is a graph of the possible slopes. Okay, so the slopes, so we have 0 at 0, 10. So at x equals 0, we have a slope of 0. So I'm going to put a green dot at the origin, because that's when y is equal to 0. That's when our slope would be equal to 0. For all of our values here on the negative side, all of these values have positive slopes. So approaching our point here, approaching this point here at the origin, all of our slopes are positive, which is above the y-axis. So all of this up here is going to be positive slopes approaching 0. Okay. And then everything to the right of our maximum has negative slopes. That was all of these slopes. So the negative values are all below the x-axis. So we end up with a line that looks like this, and this would be the graph of our tangent line. I'm sorry, a graph of our derivatives for this function. And you will notice here that we have negative x squared plus 10, so the red line is a quadratic, and our derivative was linear. It only crosses the x-axis at one point. I want to do one more example with you guys. This one is also similarly done in one of the videos that I'm also provided to you guys. So let me grab another sheet of paper here. We'll do one more of these. Okay. All right. I know I'm going a little bit fast with this. That's why I've provided a couple of different videos for you guys to watch in the event that you guys get a little confused. So, all right. So this time around, ooh, I'm bleeding. Got a paper cut. Give me just a second. I'm going to pause this video, guys. Give me just a second. All right. Let's continue here. So, okay. Took care of my finger. Finished my graph to show to you guys. So this time around, we have a W. Okay, if we count our zeros, 1, 2, 3, 4, that makes this a degree 4 function at the absolute minimum, because we'll have 4 zeros on it. Okay, does that ring some bells from pre-calculus, hopefully? So let's mark our zeros off here. So we have a 0 here. We have a 0 here. No, I'm sorry, that's totally wrong. I totally messed that up. We have a maximum there. We have a minimum here, a maximum here, and another minimum here. Okay, so those values are going to go to 0, so we will have zeros at those points. Okay. Alright, so we'll have zeros here, a 0 here, and a 0 here. Okay. Alright, so all of our slopes on this side are going to be negative, and everything past the 0 coming up this side has a positive slope to it. So we're going to have negative slopes coming up to this point. Alright. Everything here, this is becoming positive now. Positive, positive, positive. And eventually we get back to 0. So you'll notice here that we make a little bit of a turn. There's got to be a turn at some point. That comes from specifics from this function when you actually have like numbers and stuff. This is just a sketch, so it has to turn at some point because it has to come back to 0 by the time we get back to x value or x values equal to 0. So this has to turn at some point, and it comes back to 0. But what's important is that all of these slopes, all the tangent line slopes along this section here, are going to be positive, and all of these values are above the x-axis, so their y value, their slope value, would still be positive. Everything coming down this section is going to be positive. I'm sorry, has a negative slope. So we have negative slopes coming back until we hit here, and then everything on this side is positive again, shooting off this way. So if we count all of our peaks and troughs and stuff here, so we have 1, 2, 3, 4 zeros. Now we've got 1, 2, 3 zeros. So we went from a degree 4 polynomial to a degree 3 polynomial. Pretty cool. Cool. So we maintain our rule there. That is how we generate these things. I have posted another video for you guys as well, because I know that I'm not super great at this one. This is not one of my favorite topics in calculus to go over, but this is the idea of how you do it. Watch that video as well. If you have any questions, write them down, and we will address them in class when I see you guys. All right. I will see you guys next class.